Hello guys, welcome to the channel. In this video, I'll explain the problem Wi-Fi range. So let's get started. Here is the problem statement and it says that there are n rooms in a straight line in Geekland State University's hostel. You are given a binary string s of length n where si equals to 1 represents that there is a Wi-Fi in ith room or si equals to 0 represents that no Wi-Fi. Now, each Wi-Fi has a range X, which means that if there is a Wi-Fi in ith room, then its range will go up to X more rooms on its left as well as right. Now, you have to find whether student in all rooms can use Wi-Fi. Okay, let me explain the problem. So there is a hostel which contains n rooms which are present in a straight line. Now for each room there are two possibilities. Either it contains a Wi-Fi or it does not contain any Wi-Fi. So if it does not contain any Wi-Fi, then it is represented by the value 0, and if it contains Wi-Fi, then it is represented as 1. Okay, so first two rooms are not having any Wi-Fi. This room contains a Wi-Fi and these three rooms again does not contain any Wi-Fi. Okay, so if you have a Wi-Fi at any room, then this room is going to provide a Wi-Fi signal to X more rooms on the left and X more rooms on the right. Okay, which means that rooms from I minus X to I plus X are going to receive signal given that the ith room contains a Wi-Fi. Okay, now I hope it's clear to you. So we need to find whether all rooms are receiving Wi-Fi signals or not. So you can see here that this particular room is not receiving Wi-Fi signals. So in that case, the output will be 0. And if all rooms are able to get the Wi-Fi signal, in that case the output will be 1. Okay, now let me explain you this particular example. So it says that we have 5 rooms. Let me draw 5 rooms. We have 5 rooms like this. Now the first room contains a Wi-Fi, the second and third room doesn't contain any Wi-Fi, again the fourth room contains a Wi-Fi and fifth room don't have any Wi-Fi. Okay, now the first room, what is the range? The range is X, which means that if there is a Wi-Fi at this point, then one room on the left and one more room on the right is going to receive signal. Okay, now for this there is no room on the left, so this room and this room are going to receive signal. What about this room going to receive signal itself, and after that it is going to provide room signal to these two rooms as well. So now you can see that all rooms are able to receive signal at least from one Wi-Fi here. So here the output is going to be 1 in that case. Okay, now I hope the problem statement is clear to you. Let's talk about the solution. Okay, so I'll start with the brute force approach first. And I have taken one example here where I have 13 rooms and the value of X is 2, and these are the values of the binary string S, right? Okay, so the idea is simple. I'll iterate over all the values in this string, and if there is a Wi-Fi in any room, in that case I know room from I minus X to I plus X are going to receive signal, right? So I need to represent this somewhere. Okay, so I am going to take an additional array, and this array is going to tell me whether the current room, the size will be same as the number of rooms, so n will be the size. Okay, and each value in this array will represent me whether the current room is able to receive Wi-Fi signal or not. Okay, so this is going to be a Boolean array, right? Because we are going to have only two values. So let's call it a Boolean array, which is visited. Now, as I walk you through this particular example, then you will come to know yourself that why I am using this visited array. So let me write this string. I have 0 0 1 0 0 0 0 0 again 1 0 0 0 and 1. Okay, I'll start with the first element. This element is not receiving any signal till now. I mean this room. Instead of calling this element, I'll call it room. So this room is not receiving any signal till now, so the value is false. After that, this room is again not receiving any signal, so the value is false. This room contains a Wi-Fi, so it is going to receive signal, and even it is going to provide signal to two more rooms on the left and right. Why? Because the value of X is 2. Okay, so now you can see here these two rooms are able to receive signal. And what about these two rooms? These two again going to receive the signal. After that, I come to this point. This is not receiving signal. What about this? This is not receiving signal. Okay. What about this? This is not receiving signal. This room contains a Wi-Fi itself. Okay, so it is going to receive signal itself, and it is going to provide signal to two more rooms on the left and right. Fine. So now this contains like this is receiving signal, this is receiving signal, and these two are also receiving signal. Fine. After that I come to this point. This is not receiving signal till now. But when I come to this point, then you will find that these two are now receiving signal. So my task is done at this point. This is the visited array that I have filled now. Okay, now what are the value present in the visited array? You can see here that these rooms are getting the signals, but this particular room is not receiving signal from any of the Wi-Fi. This Wi-Fi, okay, let me draw the range as well. So this Wi-Fi has a range like till this point. Okay, this Wi-Fi has a range till this point. Okay, what about this Wi-Fi? This Wi-Fi has a range till this point. Okay, now you can see that this particular room is not receiving any signal here. So this is something that we need to return. Like if this room is not receiving signal, then the output will be 0 here. So the output will be 0. Okay, now I hope the idea is clear to you. Let me show you the pseudocode. Okay, here is the pseudocode here. So in the pseudocode, you can see here what I'm doing. I have a visited array, right? So I have a visited array here. Okay, and I'm going to fill this visited array. How? For all the values, like for the all the values in the string, all the values in the string that we are given a binary string, right? Okay, so if the value is 1, like if Wi-Fi, how to represent a Wi-Fi? If s of I is double equals to 1, right? Okay, now if this condition is true, in that case I need to iterate from I minus x to I plus x in order to make all the values as visited. You can see here that now these particular rooms are going to receive signal. Okay, I need I want you to know about one more case. Let's say I have an example where I have 1000 100. Okay, for this I have a Wi-Fi at starting point, right? And the value of x is 2, so it is going to receive signal, it is going to provide signal to two values on the left and two values on the right. But you can see here that there is no value on the left, right? So when I try to access these locations, then it will give me segmentation fault. Okay, how to handle this? In order to handle this, my starting point is always going to be initially it was I minus x, but I want it to be max of I minus x and 0. Why? Because if I minus x is negative, in that case I will take 0 value. Okay, what about end value? End value will be minimum of I plus x and n minus 1. Why? Because if I plus x is greater than size, if I have Wi-Fi here and I plus x will be somewhere at this point, right? So if this value is greater than the size of this array, in that case I'll take the last element, which is n minus 1. Okay, so this is the range from this start point to this end point. Now this is the idea that we are going to implement. Let me show you the code. Okay, so let me show you the starting point. This is the code that we have. On the left hand side I have the Java code, and on the right hand side I have the C++ code and the Python code. You can see that the implementation is pretty simple and straightforward. I have the visited array here of size n. After that, for each value, if the current value is 1, like if there is a Wi-Fi, in that case I am going to iterate all the way from this range and going to visit a room. Okay, now what about this thing? In this like traversal, I'm just checking if there is any value which is false. In that case I need to return false. Why? Because this particular room is not receiving any signal, and this is what I need to detect. Okay, and you can see that the C++ code is very similar to the Java code, and again the Python code is again similar to the Java code and the C++ code. Why? Because the logic is going to remain same, right? Okay, now let me talk about the time complexity. So here I'm doing O of n traversal. If you notice here that I'm checking for all the values, right? And at this point I'm going to I'm doing a traversal which is similar to O of n, not exactly but similar to O of n. Why? Because in worst case we can have like n points itself. Okay, so since this is nesting of loop, so the complexity is going to O of n square here. So this is the complexity which is not going to be accepted. So we need to optimize this thing, right? Okay, let's talk about the optimization. This is the approach 2 that we have. Now again I have written the same example. Okay, for this example I want you to notice one thing, that whenever we have a Wi-Fi at any point, right, in that case from I minus x to I plus x, we need to increment values. If you notice here, how, let me tell you. If you have a Wi-Fi here, in that case I will do plus 1 at this point, plus 1 again for this, plus 1 for this, plus 1 for this, and plus 1 for this. There are 5 values which I am incrementing. Why? Because two rooms on the left and two rooms on the right, and this particular room itself, these all these rooms are going to receive signal at least from Wi-Fi, one Wi-Fi. This is what this plus 1 means. Okay, now what about this room? This is not going to receive any signal till now. Okay, after that I have this Wi-Fi. So again, for this Wi-Fi, from I minus x to I plus x, I minus x to I plus x, I'm again going to increment the values, right? And what is this? This is basically plus 1, plus 1, plus 1, plus 1, and plus 1. This is how I'm going to increment. Okay, what about this? For this again, from I minus x to I plus x, I'm going to increment the value. So this will become plus 1, and this particular value will become plus 2 now. Interesting. What does this plus 2 means? This means that this particular room is receiving signal from two Wi-Fis. Okay, interesting. But my task is to find that particular room which is not receiving signal from any of the room Wi-Fi, right? This is not receiving signal from this as well and this as well. You can see here. Okay, in that case the output is going to be false because I have found one room. Okay, now instead of these boolean value which I was representing here, I'm representing the integer value, and there is a reason behind this. Let me tell you. If you notice at this point, then I'm performing the range sum query. On what basis I'm saying that? You can see that whenever we have a Wi-Fi, then we got a range from like I minus x to I plus x, right? So we are basically incrementing value in this range. Okay, so if you have Wi-Fi at multiple points, then this range will become different. Why? Because the value of I is changing. Okay, so I need to perform the range sum for the given range whenever we have Wi-Fi. Okay, now for this particular example, let me tell you what are the ranges that we have. I'm going to remove these values. Okay, again, for representing that particular thing, I need an integer array, and I know this. Okay, now let me remove these values as well. Fine. What I have the Wi-Fi at 0, 1, 2 second index, right? So 2 minus 2 is going to be 0, and 2 plus 2 is going to be 4. So from 0th index to 4th index, I need to increment the value by 1. This is the first index that we have. Fine. Now what is this index? This is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 8th index. So if I do 8 minus 2, then this will be 6th index. Okay, so from 6th index to 10th index, I again need to increment the values. Okay, and what about this? This is the last index, which is the 12th index. So 12th index is the last index, so there is no I plus x here. But I minus x is definitely there, and I minus x is going to be 12 minus 2, which is 10, right? Okay, so from 10 to 12, I need to increment these values. Fine. How I'm going to increment? This is the question. I'm going to tell you a trick to increment the values, and please be focused here because this is something which is really interesting and tricky to understand. Let me tell you. I have an array here which is on which I am going to increment the values. So let me write the values 0, 0, 0, 0, 0, 0, 0, 0, again 0, 0, 0, 0, and 0. These are the values that I have. Okay, from 0 to 4, 0 to 0, 1, 2, 3, 4, I need to increment the values. Okay, from 6 to 10, 6, 7, 8, 9, 10, I need to increment these values, and from 10 to 12, I need to increment values. Okay, so what I'm saying is, if you guys are aware with the concept of prefix sum, prefix sum is basically keep like when we keep adding the values behind, like if I have the array 1, 2, 3, 4, 5, then I'll just keep adding the values. I have 1 here, 1 plus 2, 3 here, 3 plus 3, 6 here, after that I have 10 here, after 15 here. This is what the prefix sum is, right? Okay, this is brief about prefix sum, and this is not even a very deep concept to explain. Now what I can do is, if I want to increment all these values by 1, so I can just increment this value by 1. Okay, and after that I can increment this value by 1. After then I can increment this value by 1. Okay, now when I perform the prefix sum, then you can see here that this value 1 will make all these values 1, right? When I perform the prefix sum, and similarly this value 1 will make all the values ahead by 1, right? And this is what it means. It means that if this particular point is receiving the Wi-Fi signal, then this one also going to receive the Wi-Fi signal. Let's perform the prefix sum. If I perform the prefix sum, then this particular value is 1. After that, this value is again 1. Okay, this value is again 1. This value is again 1. And this value is again 1. This value is again 1. Oh my god, there is something wrong here. You can see at this point again this value has become 1, but I don't want any value out of this range as 1, right? You can notice here. But computer is not going to perform this itself. As a programmer, you need to tell the computer that hey, you have to stop at this point. When you have performed the sum for a range, then just after the range you need to like cancel that sum, right? If the sum is 2 here, then just after the range is over, you need to do something like -2 here in order to make that sum 0 again. I hope you guys are getting intuition from this point. Okay, so if the sum is 1 here, then in order to make the sum 0, I'll simply do -1. Okay, makes sense. So I can do something like if my range is over, then just after the range I can do -1, right? Okay, so let me remove this value and make it -1. Now I hope you guys are able to understand why I have written -1 here, and here I have -1. So now this sum will become 0 again. Okay, after that again I have value 1 here. You can see here I have value 1 here, so I will make it 1 0. After that this will become 1 1 1. And what about this value? This value is something okay, so just after this range I need to make this -1, right? So this value will become 1, this value will become okay. At this point I already have one value which is 1, right? You can see here. So now this value will become 2. Okay, fine. And after that again this value will become 1, and this value will become 1. Okay, so this value is actually not become 1, this will become 0, right? Okay, these two will become 0. Okay, let me clear this is actually wrong. This value becomes 2. Okay, after that I have 2, so 2 minus 1 become 1 and 1. This is what the correct value is. Okay, now let me explain this. You can see here that this is something that I wanted. It is, these are receiving signal from one Wi-Fi, this is receiving signal from 0, these are receiving again from one Wi-Fi. This particular point is receiving signal from two Wi-Fi. You can see here, this is what this value represents. Okay, after that these two again are getting signal from only one Wi-Fi. Okay, this is what I wanted. So what I have explained you, let me tell you. First of all, I am making the first index. If I want to perform the prefix sum for start and end, let's say this is our range, this is our general range. Okay, so and this array is ARR. This particular array which is representing the sum is ARR. Okay, so I'll simply do ARR of ST plus equals to 1, right? And ARR of like and plus 1. Why I am writing and plus 1? Because just after the range, this is what I have cast here. So this is the point, right? So and plus 1 is going to be equal to -1 here. Why? Because I need to add -1 in order to cancel the effect of this value which is here. Okay, just after the range. Now this is what I am doing for every value in the range that we have. Okay, now this makes sense. So for each like I'm even going to write the pseudocode for this. So for each value in string, and this will make the concept more clear. So whenever I have a Wi-Fi, so if Wi-Fi is there, right, and whenever I have Wi-Fi, so I have got my range. What is the range? Okay, I've done something wrong here. Okay, now what is the range that we have got? The range is simply from I minus x to I plus x, right? So since my range is I minus x, so I'll do array of I minus x equal to plus equals to 1, plus equals to 1. After that I'll do array of I plus x, this is ending in x, plus 1. This is what I need to do, plus equals to -1 here. Now I hope the idea is clear to you. Okay, so when I'm done with this thing, then I just need to perform the prefix sum. So I'm going to write this. Okay, so if I'm at here, so I'm going to write this, perform prefix sum. And when the prefix sum is over, then I've got my array. So in that case I just need to find for actually I need it should be search for I just need to write that search for a value 0. If the value 0 is there, in that case I just need to return false, right? Let me show you the code. Code is there. I have written the Java code here. okay, and I have the C++ code as well. Now you can see at this point that what I'm doing, I have a visited array which is now of integer type, okay, and for each value, if Wi-Fi is there, if we have a Wi-Fi, in that case I will have a starting point and ending point. Now this max is again, I don't need to tell you that this is something uh, which I have done in order to avoid the segmentation fault that I can get. Okay, now I'm going to do visited of start plus equals to 1, and plus 1 is going to have a minus 1 here. Okay, now what about this? At this point I am performing the prefix sum, and this traversal is basically to check whether we have a value 0 or not. Again, the C++ code is very similar to the Java code. Now let me show you the Python code as well. So I'm going to show you the Python code. Let me show you. I have written the Python code here, so you can see that I have the okay, so this is the Python code that we have. We are first making a visited array which is of integer type, and again we are performing the prefix sum here, like prefix sum at this point, but this is the main logic that we have for in sum query. After that, we are searching for a value 0. If it is there, then return false, else return true. Okay, now till now we have discussed two approaches to solve the problem, one of which will get accepted, and one was just brute force. Okay, now what is the time complexity? So this is the time complexity where I have the time complexity as O of n and the space complexity as O of n again. Okay, fine. Now this is all about this problem, but I have one more approach in order to explain you. This is very interesting approach, and just based on the observation. Let's see what observation we have. So we have the value of x as 2, right? Okay, so if I start moving from this point, I have this point unvisited, this as unvisited till now. Here I have Wi-Fi, so this point is going to help us to like provide signal to these two rooms, right? But what if I have one more room there? Okay, so this room is something which is out of this range, like 2, right? So if I have 0 1 2 3 3 index there, so let's say this is the index of first value of 1, right? So if 3 is greater than 2, which is true, in that case I'm simply going to return false, right? So I'll first search for the first index of like first index, which index is this? This is the starting, let's call it start index. Okay, so if start is greater than x, in order to after that I'll simply return false. Okay, now what, let me take similar case for the ending as well. If I have 0 here, 0 0 0. Okay, so this is the last one that we have, right? Okay, so let's say the index of last one is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 is there. This is 13, and 14 15 16, and 16 is this. Okay, now what is the like, if this gap, I hope you will be able to understand this, if this gap is something which is again greater than 2, in that case I need to return false, right? I need to return false. How to get this range? In order to get this range, I'll simply do n minus this particular index, let's say it is I, so n minus I plus 1, right? This is the gap that we have. Okay, so after that I can simply check whether this is greater than x or not, and this is what we can do for the first and last element. But there are some elements in the middle. How to check for those? You can see here that for the first and last element there is just like these values, which is x, right? But for this range there are two values, like uh, this is x, which this one will cover, and this is again x, which this one is will cover. Okay, so in that case I'm again going to check whether this range, let me change the color, whether the gap between two ones, whether the gap between two ones is greater than 2x or not. If it is greater than 2x, in that case you can see here that let's say the value of 2x is 4, right? So these two will get signal, these two will get signal, but this will not get signal. This is the problem. So you, at this point the gap is greater than 2x. So in, if gap between two ones, if gap between two ones, right, ones is greater greater than 2x, in that case return false, return false. Now how to calculate this gap? This is something which is really based on implementation, how you implement this. So this is not a specific thing, I'm just going to show you the code now. I hope the idea is very clear to you. This is not very complex to understand. So let me show you the third approach, which is the most optimal approach, because this is going to replace the like optimize the space complexity as well. Okay, so This is the third approach that we have in Python, and this is the third approach in Java. Oh, I mean in C++. Okay, now here you can see that first of all I'm searching for the starting index. Why I'm searching for the starting like the value where I have first seen the 1. Why I'm searching for this? Because I want to check this condition, right? Okay, what this condition is? This condition simply says that if there is no any value 1. Okay, now okay, so I think I can replace this condition, like I can do something like this. Even if I do this, then again it will work fine. So here I am checking whether if this value is greater than x. In that case, I need to return false. Fine. What about this last? It says that okay, so this is basically to keep track of last occurrence of 1. But why I need this? I need this because let's say I'm at this point. Okay, so this is quite messy. Let me write it again. So I have 1 0 0 0 0 1. Let's say this is the current index where I have seen 1. So I need the last occurrence of 1 as well. Fine. This is the last occurrence of 1. So I minus last will be the gap. I hope it's clear to you. Okay, even I minus last plus 1 will be the gap. Okay, now let's see here. So I'm just checking if the gap is greater than 2 cross x plus 1. In that case, I need to return false. Okay, and whenever I see a Wi-Fi, then the last point when I have seen Wi-Fi is going to change. Last will become I. Okay, after that I'm checking the condition for the last thing. You can see here that I'm checking x plus 1. Why? Because uh, I have already explained this, but I'm just going to show you this particular case where I was checking like n minus I plus 1. Okay, now this is the code in Java. Okay, and this is the code in C++, which is very similar to the code in Java. And let me quickly show you the Python code as well. So this is the point where I have written the Python code. Now I hope everything about this problem is clear to you. So if you like the video and if you are new here, then you can subscribe the channel, hit the like button, and also share the video. This is all about this video. Thank you.